And they both have focal lengths of 100 centimeters. And the distance between mirrors is 250 centimeters, as you see. And an object A with a height of 1 centimeter is placed 250 centimeters away from the concave mirror. And the question says draw the images and find their positions and their sizes. A. If the light rays first reflect from concave mirror. B. If the light rays first reflect from the convex mirror. This slide shows the case A. As you see, light rays first come to concave mirror and then to convex mirror and form the final image A prime prime. Before starting to solve the question, I want to point out that there are actually infinitely many images when an object is placed between two mirrors, just like here, because the image formed by the first mirror, A prime, in this case, acts as the object for the second mirror, and the image formed by the second mirror acts as the object for the first mirror again and again, and this goes on like this. And therefore, there are many images formed by two mirrors in such case. At some point, an image forms at the same place as the image, uh, uh, as the real object, but the image referred in this question is the image formed just before the image which forms in the same place as the real object, which is A prime prime. So the image that the question asked about is drawn as A prime prime here. Okay, let's now talk about the case A. Actually, we can divide this case into two parts as well. First, light rays coming from object A reflects from the concave mirror. In this part, let's say first part, in this part, reflected light rays form image A prime. Okay, now let's find height of this A prime and its distance from concave mirror. We know that focal length of concave mirror is positive, and in the question it's given that it's 100 centimeters. And we know that distance object is 150 centimeters. We don't know distance image. We don't know height image. First, we need to find di. How can we find di? If we apply the formula 1 over f equals 1 over di plus 1 over do, 1 over 100 equals 1 over di plus 1 over 150. So di is 300 centimeters. We also that magnification is equal to hi over ho, and this is equal to di over do. We found that di is 300 centimeters and do is 150 centimeters. So this ratio is equal to 2, and we know that height object is 1 centimeters. So height image is 2 centimeters. This is for A prime. For the second part um, of this question, let's think about the second mirror. What happens when the light rays reflect from the convex mirror? In this case, image A prime acts as the object for this convex mirror, and it is 50 centimeters away from the convex mirror. Since 300 and since this distance is 300 centimeters, and since this is 250 centimeters, we know that this distance is 50 centimeters. So distance object in this case is 50 centimeters. Here we should be careful with the signs because this is a convex mirror. And do is negative 50 centimeters because the object A prime is behind the mirror. Since this is a convex mirror, it also has a negative focal length, which is 100 centimeters. And therefore, focal length is negative 100 centimeters. Again, if we use the formula 1 over f equals 1 over di plus 1 over do, we find that um, di is positive 100 centimeters. As you see, distance object is 100 centimeters from the convex mirror, and it is positive, so it's in front of the mirror. To find the height of image A prime, we use again hi over ho equals di over do. Um, di is 100 centimeters, do is 50. This ratio is again 2, and this is equal to ho is now 2 centimeters. So hi is 4 centimeters for A prime prime. This question, the light rays first come to the convex mirror and then to the concave mirror. So image is again 150 centimeters. Object is 150 centimeters away from the concave mirror. So it is 100 centimeters away from the convex mirror. So distance object is 100 centimeters for image A prime. Light rays coming from object A results in this image A prime. As you see, distance image will come out to be negative because it forms behind the mirror and it's a virtual mirror, but we'll find this later. And since it's a convex mirror, we know that focal length is negative 100 centimeters. Okay, by using 1 over f equals 1 over di plus 1 over do formula again, 1 over negative 100 equals 1 over di plus 1 over 100. The di is negative 50 centimeters. This negative sign again indicates the image is virtual behind the mirror and it's upright, as you see. And image A prime acts now. Image A prime acts as the object for the concave mirror. Now, for A prime prime image, distance object to the concave mirror is 250 centimeters plus 50 centimeters, so it is 300 centimeters. Um, and focal length is now positive 100 centimeters because light rays reflect from the concave mirror. Again, using the same formula, 1 over f equals 1 over di plus 1 over do. We can find di. 1 over 100 equals 1 over di plus 1 over 300. Then di is equal to 300 over 2, 150 centimeters. So the final image A prime prime is 150 centimeters away from the concave mirror, and we need to find its height right now. First, by using hi over ho equals di over do formula, let's find the height of image A prime. This is equal to di over do. We found that di is 50 and do was 100 centimeters. So, and ho was 1, then hi must have been 0.5 centimeters. For the A prime prime part, let's do this again. Hi over ho equals di over do. We found that di is 150 centimeters, do is 300 centimeters. Again, this is 1 over 2. Since HO was 0.5 centimeters and this ratio is equal to 1 half, HI is 0.5 25 centimeters, so it is 1/4 um, of object A.